Heat transfer test questions number 4. Question 1. The potential difference in an electrical system is analogously considered as A. A temperature difference in the heat transfer system. B. A current flow in the heat transfer system. C. A resistance in the heat transfer system. D. None of the above.
Answer: a temperature difference in the heat transfer system.
Question 2. Thermal conductivity of the same material varies with A. The thickness of the material. B. The temperature of the material. C. Both A and B. D. Thermal conductivity of the same material does not vary at all.
Answer: the temperature of the material.
Question 3. The surface temperatures of a plate with thickness of 0.06 meters are 100 degrees Celsius and 40 degrees Celsius. The thermal conductivity K of wall is 350 W, mK. What is the rate of heat transfer through the plate in kW/heat transfer through the plate in kW/m2? A. 350,000. B. 350. C. 35. D. 0.
Answer: 350.
Question 4. How does the thermal conductivity of a material change with respect to change in temperature of the same material? A. Thermal conductivity of a material increases with increase in its temperature. B. Thermal conductivity of a material decreases with increase in its temperature. C. Thermal conductivity of a material remains same with change in its temperature. D. Unpredictable.
Answer: thermal conductivity of a material increases with increase in its temperature.
Question 5. What does a composite wall mean? A. Two walls of different materials are connected in series without any gap between them. B. Three walls of different materials are connected in series without any gap between them. C. More than three walls of different materials are connected in series without any gap between them. D. All of the above.
Answer: all of the above.
Question 6. Why is the Buckingham theorem used? A. To determine number of dependent dimensionless groups which are necessary to represent the phenomenon in a mathematical expression. B. To determine number of independent dimensionless groups which are necessary to represent the phenomenon in a mathematical expression. C. To determine number of dependent groups with their dimensions which are necessary to represent the phenomenon in a mathematical expression. D. To determine number of independent groups with their dimensions which are necessary to represent the phenomenon in a mathematical expression.
Answer: to determine number of independent dimensionless groups which are necessary to represent the phenomenon in a mathematical expression.
Question 7. Which of the following dimensions is our primary dimension, S? A. Length L. B. Time T. C. Temperature T. D. All of the above.
Answer: all of the above.
Question 8. The principle of similarity or model law states that A. If the ratios of linear dimensions, forces, velocities, etc. of two systems are the same, then their behavior will be different as per the dimensions. B. If the ratios of linear dimensions, forces, velocities, etc. of two systems are the same, then their behavior will be similar. C. If the ratios of linear dimensions, forces, velocities, etc. of two systems are different, then only their behavior will be similar. D. D. None of the above.
Answer: if the ratios of linear dimensions, forces, velocities, etc. of two systems are the same, then their behavior will be similar.
Question 9. Wien's displacement law gives the relationship between A. The wavelength of radiation at which total emissive power is maximum and the temperature. B. The wavelength of radiation at which total emissive power is minimum and the temperature. C. The wavelength of radiation at which total emissive power does not change and the temperature. D. None of the above.
Answer: the wavelength of radiation at which total emissive power is maximum and the temperature.
Question 10. The emissive power of gray body is A. Less than the emissive power of the black body. B. Greater than the emissive power of the black body. C. Equal to the emissive power of the black body. D. Cannot say.
Answer: less than the emissive power of the black body.
Question 11. What is the intensity of radiation I? A. Rate of heat radiation from a surface per unit area. B. Rate of heat radiation from a surface per unit solid angle. C. Rate of heat radiation from a surface per unit area per unit solid angle. D. None of the above.
Answer: rate of heat radiation from a surface per unit area per unit solid angle.
Question 12. What is solid angle? A. The ratio of spherical surface enclosed by a cone, with its vertex at the center of sphere, to the radius of the sphere. B. The ratio of spherical surface enclosed by a cone, with its vertex at the center of sphere, to the square of the radius of the sphere. C. The ratio of spherical surface enclosed by a cone, with its vertex at the center of sphere, to the cube of the radius of the sphere. D. The ratio of spherical surface enclosed by a cone, with its vertex at the center of sphere, to the fourth power of the radius of the sphere.
Answer: the ratio of spherical surface enclosed by a cone, with its vertex at the center of sphere, to the square of the radius of the sphere.
Question 13. The radiation heat exchange between two bodies depends upon A. The views of two surfaces with each other. B. The medium between the two bodies. C. Emitting and absorbing characteristics of the bodies. D. All of the above.
Answer: all of the above.
Question 14. Shape factor is also called as A. View factor. B. Geometry factor. C. Configuration factor. D. All of the above.
Answer: all of the above.
Question 15. How does heat flux change with increasing excess temperature in transition boiling regime of boiling heat transfer process? A. Heat flux increases with increasing excess temperature. B. Heat flux decreases with increasing excess temperature. C. Heat flux becomes constant with increasing excess temperature. D. None of the above.
Answer: heat flux decreases with increasing excess temperature.
Question 16. Which regime in boiling heat transfer process can represent a transition from nucleate boiling to film boiling? A. Pure convection regime. B. Nucleate boiling regime. C. Transition boiling regime. D. Stable film boiling regime.
Answer: transition boiling regime.
Question 17. The nuclei of bubbles form in nucleate boiling, when there is presence of A. Superheated vapor. B. Superheated liquid. C. Dissolved gases. D. Undissolved gases.
Answer: dissolved gases.
Question 18. When is the condensate flow almost always a laminar? A. When condensation occurs on a horizontal tube. B. When condensation occurs on a vertical bank of horizontal tubes. C. When condensation occurs on a vertical tube. D. When condensation occurs on a bunch of vertical tubes.
Answer: when condensation occurs on a horizontal tube.
Question 19. In forced convection boiling process, a liquid flows through a tube with A. Superheated or unsaturated boiling. B. Subcooled or saturated boiling. C. Subcooled to superheated boiling. D. Vapor in boiling.
Answer: subcooled or saturated boiling.
Question 20. Consider a plane wall of finite thickness having energy generation in it. The sum of the rate of heat energy generation in the wall and rate of energy transfer by conduction into the wall is equal to A. Rate of heat transfer by conduction out of the wall. B. Rate of the wall. B. Rate of heat transfer by convection out of the wall. C. Both A and B. D. None of the.
Answer: rate of heat transfer by conduction out of the wall.
Question 21. What is the purpose of using fins in a particular heat transfer system? A. To decrease rate of heat transfer. B. To increase rate of heat transfer. C. To maintain rate of heat transfer at a constant rate. D. Cannot say.
Answer: to increase rate of heat transfer.
Question 22. Temperature at the end tip of the fin having uniform cross-sectional area is A. Maximum. B. Minimum. C. Similar to the heat generation temperature. D. Unpredictable.
Answer: minimum.
Question 23. In the process of heat transfer through extended surfaces or fins, the entire surface area is at A. The same constant temperature. B. Different temperatures. C. Maximum base temperature. D. Minimum temperature.
Answer: different temperatures.
Question 24. What is the relation between the intensity of radiation and the thickness of the layer, in case of gas? A. The intensity of radiation increases with increase in the thickness of gas layer. B. The intensity of radiation decreases with increase in the thickness of gas layer. C. The intensity of radiation remains unaffected with change in the thickness of gas layer. D. Unpredictable.
Answer: the intensity of radiation decreases with increase in the thickness of gas layer.
Question 25. 90% of the incident radiation on glass in the visible range is A. Absorbed. B. Reflected. C. Transmitted. D. None of the above.
Answer: transmitted.
Question 26. In greenhouse effect, the only infrared radiations A. Are allowed to exit from the interior surface. B. Are not allowed to exit from the interior surface. C. Cannot absorb heat energy. D. None of the above.
Answer: are not allowed to exit from the interior surface.
Question 27. How is the greenhouse effect experienced on Earth? A. Global warming. B. Pollution. C. Both A and B. D. None of the above.
Answer: global warming.
Question 28. Which of the following gases are responsible for global warming? A. Carbon dioxide CO2. B. Water vapor H2O. C. Both A and B. D. None of the above.
Answer: both A and B.
Question 29. In desert areas, there is large difference between day and night temperatures mainly because of A. Presence of carbon dioxide in air as it acts as barrier for emanating infrared radiation from the Earth's surface. B. Presence of water vapor in air as it acts as barrier for emanating infrared radiation from the Earth's surface. C. Absence of carbon dioxide in air as it acts as barrier for emanating infrared radiation from the Earth's surface. D. Absence of water vapor in air as it acts as barrier for emanating infrared radiation from the Earth's surface.
Answer: absence of water vapor in air as it acts as barrier for emanating infrared radiation from the Earth's surface.
Question 30. How is the cooling at night in coastal areas? A. The day temperature reduces rapidly at night in coastal areas. B. The day temperature reduces slowly at night in coastal areas. C. The day temperature and a night temperature in coastal areas are similar. D. Unpredictable.
Answer: the day temperature reduces slowly at night in coastal areas.
Question 31. The radiation energy from the Sun is produced by A. Fission reaction, B. Fusion reaction, C. Both A and B, D. None of the above.
Answer: fusion reaction.
Question 32. The rate at which the solar energy reaching the Earth's atmosphere is called as A. Solar constant, B. Radiation constant, C. Electromagnetic constant, D. Atmospheric constant.
Answer: solar constant.
Question 33. The radiation from fusion of hydrogen A. Can be achieved on Earth's surface, B. Cannot be achieved on Earth's surface, C. Can be achieved on Earth's surface at high maintained temperature, D. Unpredictable.
Answer: cannot be achieved on Earth's surface.
Question 34. What is the purpose of using baffles in shell and tube heat exchangers? A. To maintain uniform spacing between tubes, B. To enhance heat transfer, C. Both A and B, D. None of the above.
Answer: both A and B.
Question 35. Large-sized and heavy shell and tube heat exchangers are suitable for A. Automotive applications, B. Aircraft applications, C. Marine applications, D. None of the above.
Answer: none of the above.
Question 36. Which side is suitable to provide fins on to enhance heat transfer, when heat exchanges between gas and liquid? A. Gas side, B. Liquid side, C. None of the sides.
Answer: gases side.
Question 37. The scales form in heat exchangers after a period of operation and provide additional resistance to heat transfer with some heat transfer coefficient. The reciprocal of this scale heat transfer coefficient is called as A. Scaling factor, B. Fouling factor, B. Fouling factor, C. Forming factor, D. Resisting.
Answer: fouling factor.
Question 38. Which type of flow in heat exchanger is represented in below diagram? A. Parallel flow heat exchanger, B. Counterflow heat exchanger, C. Cross-flow heat exchanger, D. None of the above.
Answer: parallel flow heat exchanger.
Thanks for watching. Please comment, like and share.